I saw a lot of good presentations and also realized a lot of alignment in terms of thinking, which is awesome because I think this is what the industry needs to be successful in the future. Okay, so you heard about the title?
Arno, maybe a second. I think we have a technician fixing your headset.
Okay, awesome. Cool. Does the clicker work? No, it doesn't. Maybe it's the other one.
Let's see if this one works. No superpowers yet.
No superpowers yet, yeah. So
could another technician help us, please?
Okay. All right, so we help engineers to build better vehicles faster and with more confidence. And, okay. Maybe it's you guys doing this. I appreciate it. And in the past, better mainly meant really better performance, reducing cost, differentiating to a great extent. However, definition of better has changed over time, as we all know, right? These days, better also is really about improving or reducing the environmental impact. It's about things like CO2, scrap, and waste reduction. And in addition, there is a skill gap that everyone really suffers from, OEMs and suppliers alike, which means that everyone gets pushed towards automation and simplification of processes, embracing new ways of working. Automation also helps reducing engineering cycle time, obviously one of the key drivers for development time and for development cost. And it also helps reduce human error and to accelerate the speed of innovation. Systems level optimization and smart buy versus build decisions are really crucial for being successful in the future, to be able to iterate quickly and progress and learn as you get more information about the system that you're building. And finally, in the past, careful and exhaustive planning and quality assurance has been at the heart of the system, including really development and also delivery in the end. However, during times of disruption and change across all dimensions, from technology to supply chain, this approach is actually risky. And some of my, some of the other presenters really alluded to the fact, and I completely agree. Exactly. So if you're in a world that really undergoes rapid change, speed actually becomes safety. And that's kind of counterintuitive to some extent. But what it really means is similar to what has been presented in the context of SPICE. It's really about avoiding exhaustive waterfall planning where possible. It's about moving in a more agile way towards incremental exploration and also the opportunity to explore what-if scenarios. It's about adjusting quickly to change and requirements as they arise. And it's also about accelerating the speed of learning and innovation to stay relevant. This includes learning from competitors. Let's take the EV powertrain, for example, and how leading EV startups really manage to lower cost and weight by up to 40%, while at the same time shortening the development cycle time by 50%. This is a result of systems-level optimization, reducing complexity, particularly the number of parts, as well as aggressive adoption of modern practices. In fact, we see a rapid proliferation of such practices thanks to competitive benchmarking, where early adopters tend to compete more successfully in the market than followers. Interestingly, and again, it's not a surprise, we had some presentations that touch on this topic. There are opportunities to learn from software engineering. Software engineers arguably build the most complex systems on the planet. Sometimes thousands of individuals need to collaborate to deliver software to spec, on time, with a rapidly changing technology landscape. Core enablers include end-to-end lifecycle integration and automation, from feature definition to delivery and operations, as well as multi-user collaboration with change tracking and agile incremental iterations. Paired with the idea of shifting left, which of course is a really powerful idea because it really just means that you move to the beginning, as much to the beginning of the whole product lifecycle to avoid costly mistakes down the road. All of this is really standard practices in the software industry today with standard tools and processes. This, okay. Excellent. This graph really shows the main EVs in China, and it really illustrates, by the way, the x-axis is the length of the vehicle, just segmenting the market. The y-axis is CO2 in tons for 125,000 kilometers. It really illustrates why governments want to connect subsidies and CO2 performance. Our assessment really shows that a rather large variation in CO2 emissions, ranging from 10 to 30 tons, depends on many different aspects, from size to body type, of course, to battery technology and supply chain localization. To stay competitive, car manufacturers will be forced to optimize across all of those dimensions. Okay, so this is a more concrete example. And here you can see the Ford F-150 cross-car beam and the combined impact of different steps that you can undertake to reduce CO2. On the left, you can see the baseline. Here, the part is manufactured in Mexico, using magnesium, and you see the total CO2 based on the different components. In the middle, you can see the impact of really switching to 40% recycled magnesium. And as you can see, the CO2 footprint drops dramatically by 27%. And now we insource. So if you produce the same part in the US, then this combination of insourcing and local production improves the result even further. So as demonstrated with this example, saving opportunities due to compounding effects can be really quite dramatic. Okay, so we've shown you a few examples of things that we see in reality, and we strongly believe in the power of what-if scenarios. And in fast, agile iterations across the whole life cycle, across the whole product life cycle. And we invest in AI-enabled automation for competitive benchmarking, CO2 and cost-value engineering, engineering co-pilots, and we believe that's kind of the future, where agents that collaborate with me really provide real-time feedback, real-time KPIs, as you explore the space of potential solutions. We also think that holistic systems-level optimization, you've seen an example, requires cross-discipline collaboration and integrated workflows. We have seen also before an example how you would integrate certain three-letter acronyms across the manufacturing life cycle. And in our case, based on the biggest automotive database on the planet, we try to provide really a standardized approach for delivering more transparency in terms of uncovering also new trends, accelerating industry-wide learning, and also really driving differentiation for our customers, and ultimately give our customers superpowers to engineer more affordable and greener vehicles faster. We are Atomic One, you may have wondered, the industry-leading platform for automotive benchmarking and competitive insights. We're here to help you to decode the future of vehicle engineering. Thank you.
Good, thank you, Arno.